Hey YouTube, it is James.Cubes, and this is our program. I've gone ahead and made the font size a little bit bigger. And anyways, let's get right into this. So, in the last video, we checked out fill, stroke, and stroke weight. So, what we have so far is this. But now we are going to learn another function. Just because I forgot it. Background. So, background is just like any other thing, except it's pretty obvious what it does. It changes the background using grayscale, RGB, or alpha. So we'll just go ahead and set it to pure white. And here's our program. Yes. So pretty boring, what? So today we are going to learn about mostly variables. Now you may remember from my Objective-C tutorials that a variable is something that can store data. Now, a lot of the data types in processing are similar to Objective-C, so let's look at data types. Actually, let's do that at the top. So, data types for example, what is a number? Well, we could think of it as an integer as a synonym to number. So, what's in Objective-C, we use int. In Java, we also use int. So, what is the format for writing in it? We type the data type. So, data type. Then we type the variable name, and then we type equals the value, semicolon. So, if that's how we create a variable, let's go ahead and do that. So, we're going to say int I, why not, equals our value, let's just say 23, semicolon. So, now what if we want to use this? We could just say stroke weight. We could say 23, but why? We just made this awesome variable I. Let's use I. See what we get. Whoa! So, that's our program. Now, what if we want to have something that subtracts or changes? Well, that's why variables are handy, because we can affect them with our program. I equal, and if we want to access it to change it, how would we say that? We'd say, well, the variable I equals, what do we want it to say? Well, we want to use the variable I, so it's going to equal itself, but we're going to subtract a value. So, that's only going to run once, so we have to put that in our loop. So, this is what it's going to do for us now. Wow. What if we want to not do it? Let's do 0.1. It'll go slower, won't it? But what's this error we get? Cannot convert from float to int. So what it's saying is the variable I is an int, not a decimal. So why are we giving it a decimal value? Well, that's an error. So why? What can we do? We can change this to a different data type. We can change it to a float. Float f equals, let's set it to 23 so we can just change it. F, no, that's a pretty long line of code just to change it. We want to change it. What if we have tons of variables? What are we going to do then? Well, programmers got tired of this, so when they started creating new programs, they did a shortcut. So what do? You type the variable name, and then you click, what do we want to do to it? We want to, no, we don't want to add, we want to subtract. And if we want to, then you say f subtract equals, f minus equals the value you want to subtract. So what is this going to do for us? It's going to make it much slower. Well, we keep getting this error. Let me stop this program because it's an error. So it says negative width, and what that's meaning is f is going to f is going to be negative. F is negative, and if you have a negative display a negative, what's that mean? So it's an error. The computer doesn't know what it means. So what are we going to do about this? Well, we could use something called an if statement. And why not? We'll teach you, I guess in processing they call it conditional statement. A conditional statement. So how do we write this? You write if, well, if, that's simple. You don't write if f is greater, no. The computer wants an error. Why? So what are we going to do now? We're going to put it all in this. So if, if what? So in here is going to be what? If what? Sorry if I'm a little more quiet. If what? Well, if f, as long as it is greater than 0, then subtract 1 or 0.1 from f. Well, it's still an error, because when it's a 0 stroke weight, you just say no stroke weight. So as long as it's greater than 0 plus 0 plus this amount, so 0.1, so as long as it's greater than 0.01 or 0.1. Do we get an error? No, we don't. Now, let's do something more. What if we want to have, let's completely delete all our programs so far, and I'll show you what we are going to do next. So we're pretty much cleared out. So what are we going to do? We are going to create a program that's an animated program. So how are we going to do this? we are going to use our ellipse function. Ellipse. So we're going to go ahead, but we're not going to do anything. We're going to draw the ellipse at a certain point. So we're going to do float, because we want to be able to change this. So we're going to have a float for x. So float x equals, well, 640. We want us to be at the very middle. So we're going to do 640 divided by x equals 640 divided by 2. Now, what if we want to refer to this later, 640? So, a keyword that we can use, global, is width. So, if we type x equals width divided by 2, then it's going to set it at the middle of the width. Now, let's add a variable, I can't speak today, called y for our y location. Now, what are we going to do for our height? Well, we could do 360 divided by 2, but if width has a keyword, why wouldn't height? So we'll type height, but we really don't want it to be at height divided by 2. We want it to simply be at height, right? Because if height is at the bottom, well, we could do height divided by 2. No, let's keep it the same. So we can start it at the bottom and bounce it. But that wouldn't really make sense, so let's just put it at the very top. Considering our graphing system, this would be really handy to have a whiteboard. Our graphing system for our y starts at the top right corner, right here. Then our x goes over and our y goes down. So this would be height, the very bottom. So we want it at 0, so we can like drop it basically. So what are all those variables good for if we don't use them? So let's go ahead and use them. We are going to put an ellipse at x, y with the diameter of 50. What's that going to do? Hold on. I'm going to implement a method called translate, where we can have 0 at our new location. So we're going to set it to 0, 0. You do not really need to know what that means, but why is that not working? There we go. I don't know what is wrong. It's weird. I'm sorry. So we're going to draw an ellipse at just 320. And, well, how are we going to drop it? We're going to say y plus equals, that's our handy shortcut, point, let's do 3. Just for an example. So that's going to drop. But we notice how there's this strike. Why is that? Well, that's because the previous ellipses are still there. So what are we going to do? Well, every time we run this, we can delete it by redoing the background over it, and it'll look much cleaner. So we'll type background, and let's go ahead and keep it at 66. Or not 66, let's just put it at 255. So, as you can see now, it looks much better. Actually, let's make this 0.7. So, what we want to put our y speed into a variable. So let's put float y speed, or just speed for this example, equals 0.7 speed. So y plus equals speed. And if you evaluate this, you can just evaluate it like algebra. Y is equal to y plus speed. Y is equal to 0, speed is equal to 0.7. You can just evaluate it like algebra. And that's exactly what the computer does. So now, when do we want it to stop? Because right now, at 0.7 speed, it's going to go down, and it's not going to stop. It's just going to keep on going. So we are now going to use our if statement. If y is less than height minus speed. So what this is saying is, as long as the y is less than the bottom, going up the speed, because it's going down 0.7 pixels at a time, then keep on going. So we're good there, and now it should stop at the bottom. But what if we wanted to go back up? So if that's false, then we can do else, or no, I'm not going to teach you else. We're just going to have it stop, and we're going to say plus a negative. So we're going to say speed, we're going to equals negative 0.7. Speed equals negative 0.7. Wait, that's not right. We're going to use another if statement. If y is greater than height minus speed, speed is going to equal negative 0.7. So what's this going to do? So it's going to bounce all the way down really slowly, and then it's going to bounce up. Is that good? Well, now we have to add that all into another line. This video is getting really long, so let me just do this real quick. So that's our program. In the next video, I'm going to teach you how to make it much simpler. But anyways, let's end this video. So let me increase speed to 2.5 because I need to hurry this. Go, go, go. So then it's going to bounce down. No, it's not. Oh yeah. 2.5. 2.5. Okay, I'm going to explain what's wrong with that in the next video, but anyways, bye!